Hey guys, so today we're going to be discussing Leetcode question 70, climbing stairs. So the question is, you are climbing a staircase. It takes n steps to reach the top. Each time you can either climb 1 or 2 steps. In how many distinct ways can you climb to the top? So the condition here is number of steps one can climb at any point of time is 1 or 2 steps. Alright, so let's start from the very base case, which is n equals to 0. So the answer here would be 0 because we don't need to climb anything, right? So we just say answer is equals to 0. Now let's say n equals to 1. For this, answer would be 1. How? Because to climb one staircase, what are the ways that we can climb one staircase? Just one, which is climbing one staircase. Now let's analyze the other scenario, n equals to 2. How can we break this scenario down? So we have to climb 2 staircases. What are the possible ways to do that? We climb one staircase, then another, or we take 2 steps directly. So the number of ways to climb 2 staircases is answer equals to 2. So let these scenarios be our base cases, which we'll use when computing for higher cases, higher values of n, as we're going to be using dynamic approach. So these base cases would help us in computing values for higher values. So now let's analyze for n equals to 3. If we analyze this scenario, number of ways to climb 3 staircases is 1 step, 1 step, then 1 step, or 1 step, then 2 steps, or 2 steps and then 1 step. So how many ways are there to climb 3 staircases? Answer is equals to 3. 1, 2 and 3. So how can we understand this scenario? So if we have to use our base cases, how can we relate this to our base cases scenario? So notice that if we have to climb n equals to 3, so we can either take 2 steps from n equals to 1, or 1 step and 1 step from n equals to 1, or we would have to go from n equals to 2 and take 1 step from there, because our original condition was what? Number of steps one can climb is 1 or 2 steps. So to find the answer for n equals to 3, we need to know the value of n equals to 1 and n equals to 2. So this problem essentially boils down to what are the ways to climb n equals to 1 and n equals to 2. So let's understand this scenario using an array representation. So let's say we have n equals to 4, which is basically, n equals to 3. 0 step, first step, second step, and then third staircase. So as we fill in the values for our base cases, this is the DP array, dynamic programming array. So for DP0, the value is 0, index 1, value is 1, index 2, value is 2, as we had computed for our base cases, 0, 1 and 2. Now for n equals to 3, what are the ways to calculate the number of ways to climb one staircase? So this is this. The number of staircase is 1 and the number of ways is 1. The number of staircase is 2, the corresponding number is 2. So what are the ways to get to n equals to 3 from n equals to 1? One is this and then this, or the other way is this directly, right? What are the ways to get from n equals to 2? This is this directly. So what is the answer? Answer is essentially 2, which is the number of ways from 1, and 1, which is the number of ways from n equals to 2, which totals up to n equals to 3, which we can verify from here. This can be easily verified from here. We have 3 ways to do that. So our problem essentially becomes number of ways for n equals to 3, number of ways to climb 3 staircases is number of ways to climb n equals to 2 staircases, and number of ways to climb n equals to 1 staircase. So this is a hypothesis. Let's verify this hypothesis from further cases. So let's now calculate for n equals to 4. So what are the ways to get to the 4th staircase? Take one step, then third, then fourth. The other way is take one step, then take another step, then take 2 steps. The other case is take one step, then take 2 steps, then take 1 step. The other scenario is take one step plus then 1 step, take 2 steps, then 1 step, then 1 step. The final scenario being 2 steps and then 2 steps. So in this case, the answer is 5. There are 5 ways to get to 4 staircases. So again, if we need to reach n equals to 4, and we can only take 1 step or 2 steps at a time. So to reach n equals to 4, what was the last step that we can possibly go to? N equals to 3, that is by taking 1 step from n equals to 3 we can reach n equals to 4, or maximum by to n equals to 2, from where we take 2 steps or multiple 1 steps to reach n equals to 4. So this problem then breaks down into what are the ways to reach n equals to 3 plus ways to reach n equals to 2. This would give us answer for n equals to 4. So let's understand this in array representation. So let's say suppose this is the DP array that we have. DP 0 staircase, 1st, 2nd, 3rd and 4th. So filling in the values for base cases, which is obvious, and for n equals 3 we computed it in our previous case, which was 3. Now for n equals to 4, let's say what are the ways to calculate n equals to 3 to reach n equals to 3? These many ways. What are the ways to reach n equals to 2? So what are the ways to reach from n equals to 2 or n equals to 3? That is basically the 2nd staircase or the 3rd staircase to the 4th staircase, that is 2 plus 3, which is 5. Is this true? Can we verify this? So this is essentially this, hence verified. Let's verify our hypothesis with one more case, n equals to 5. So again, before proceeding to ahead, again the hypothesis we used is dp of 4 is equals to dp 4 minus 1, that is 1 step behind from 4, or 2 steps behind from 4. This is essentially dp 4 equals to dp 3 plus dp 2, which is essentially I, or you can say k, dp k minus 1 plus dp k minus 2. K is equals to 4. So now let's move ahead and check for n equals to 5. N equals to 5. So what are the ways for n equals to 5 to reach n equals to 5 step? So take 1 step, 1 step, 1 step, 1 step, 1 step, total 5 steps, or 1 step, then 1 step, then 1 step, then 2 steps, or take 1 step, then 1 step, then 2 step, then 1 step, or 1 step, 2 step, then 1 step, then 1 step, or 2 step plus 1 step plus 1 step plus 1 step, or 1 step plus 2 steps plus 2 steps, or 2 steps plus 1 step plus 2 steps, or 2 steps plus 2 steps plus 1 step. So how many are these cases? 1, 2, 3, 4, 5, 6, 7, 8. So answer is equals to 5. This problem can be broken down into, if we have to reach n equals to 5, if we have to reach the 5th staircase, since we are on, sorry, my bad, Since we're only allowed to take,
then what we can do,
since we're only allowed to take one step or two steps at a time. So what is one step back from n equals to 5? That is n equals to 4. What is two steps back from n equals to 5? That is n equals to 3. Therefore, answer for this would be ways to reach n equals to 3 plus ways to reach n equals to 4. This would give us two ways to reach n equals to 5. So let's verify this. So let's verify this using our array representation. Let's say this is the DP array that we have. 0, 1, 2, 3, 4 and 5. The index is representing the number of stairs that we have to climb. So for 0 we have 0, for 1 we have 1, for 2 staircases we have 2. As we had computed earlier, for n equals to 3 and n equals to 4 we had values 3 and 5. So for n equals to 5 we need to calculate how many ways can we get from n equals to 3 and how many ways can we get from n equals to 4, which is 3 plus 5, that is 8. Does this verify what we have calculated here? So notice that this 8 value is, oh my bad, sorry, this would be 8 not 5, my apologies for that. So these are the same values, this value that we computed by going through all test cases, or this value that we computed using our recurrence. So now we define our heart of the algorithm for the dynamic programming approach, which is essentially this. So what is the heart of algorithm? The heart of the algorithm always comprises of 3 parts. It's a very good way to represent dynamic programming problems, so that one can easily communicate the idea of the approach that you're using in your dynamic programming to everyone else. So the first part is always verbal description of sub-problems. In this case, it is essentially S of k, or should I say the DP array, whatever array name that you're using, at index k is, what does it represent? Sorry, my bad. What does it represent? Number of ways to climb k stairs. So the next part of the heart of the algorithm is what is the recurrence that we're going to be using? Since dynamic programming approach uses previous values to calculate the new values, right? So what is the recurrence that is going to be using? So for base cases, we have to define base cases, right? So for base cases, we have S, or should I say DP 0, that is ways to climb 0 staircase 0. For one staircase 1, and for the second staircase ways is 2. What is the mathematic recurrence? How are we going to compute new values from previous value? So the recurrence formula for that is dp at index k is equals to, as we had computed, since need to go one step back and calculate the number of ways from there and add it to the number of ways from 2 steps back from where we have to reach, that is dpk minus 2. Note the condition here is provided these terms exist, that is k is greater than 2. The next part of the heart of the algorithm is, sorry, my bad, where is the solution found? So we have an array of n index. So where is the solution found in that? Since we're computing it for every value, the answer for our problem would be present at the last index dp, let's say n being the number of staircase for which we had to calculate the value. So this is what? This is the last element of dp array, which essentially represents ways to climb n stairs, which is what the question was asking. So what is the algorithm for that? So before moving forward, this is the heart of the algorithm. So now what is the actual algorithm? How do we write the code for that? So the pseudo code for that looks something like this. Initialize a dp array of length n plus 1. Since we'll be starting from 0 and going till index n, so we need to initialize the array for n plus 1. Then initialize base cases dp0 equals to 0, dp1 equals to 1, dp2 equals to 2. Note, if the n value that we are supposed to compute with is greater than equal to 2, because if the question is asking for n equals to 1, then we need not go further. The third is basically where we compute our values for n equals to 3 and greater than that. So for that, use a loop from which basically is in the range 3. It starts from 3 and it goes up till n. Note that n is inclusive and 3 is also inclusive. And what are we supposed to do inside that loop? So for every dp, let's say I is the index that you're using, that should be equal to dp I minus 1. What are the ways to reach one step before it, and what are the ways to reach two steps before it? This loop should run till value n, and once we have computed this loop, once we have finished this loop, then we need to return dp n, which is essentially where a solution is stored. So this is the actual pseudo code for the algorithm. So this is how we solve climbing stairs using dynamic programming approach. I hope you guys liked this video and found this video helpful. I have attached a link to the actual code in Java in the GitHub link below in the video. You can use that to refer if you have any doubts. I have also attached a link to my custom tech blog where I write blogs regarding my what I explore in tech field, what I learn in tech field, problems I've faced, how I've solved them. I hope you find that blogs as well. Please check that out. If you like it, please let me know. And thank you guys for watching this video. Thank you for your time and keep coding.